Good morning, everybody. I'm Art Lancaster. I'm co-founder of a company called Affinegy, and we're based in Austin, Texas. We're another small company that's part of this alliance. We joined fairly early in January of this year, and it's amazing to me all the energy we have today in this conference, and it's just truly exciting. Our company is a network management company. We started in managing home networks almost 12 years ago. And so we only evolved out over time to managing wide area networks and devices. Our customers are, even though we're a small company, rather large broadband operators are our primary customers. Companies like Time Warner Cable, Cablevision, and we've also managed to have international customers. We've got an office in Poland, and we have customers like Telecom South Africa that are tier one, the telco of that country. And so it's been an exciting business and an exciting time. This alliance and what we do, we heard a lot of good talks yesterday in the keynotes on the importance of open source. Our company only really started doing open source a couple years ago and thinking about how do we benefit from that. We've been religiously focused on standards from the beginning of our company. Standards themselves are wonderful and horribly important. We're very active in the broadband forum, and any of you that are broadband operators in this audience will realize those standards are key, but you'll also know, in our case, we have probably almost 20 vendors of gateways that we support with our TR69 ACS, Auto Configuration Server. Every single one of them has some custom profile plugin we had to write to make them work. There's a litany of vendor-specific parameters, but in addition to that, the protocol implementation, the stack isn't even consistent. Open source, like we're doing in this alliance, is a wonderful way to have real things implemented, and you document what you do and create things that actually interoperate just like the internet does. And so I feel like we're going back to the future. The internet is in our home now, and the same model is the approach. And from the point of doing open source, think of companies like MySQL and Red Hat. What do? They use open source, they drive the initiative, but on top of that, they provide full service and support, because most companies that are our customers and customers of open source focused companies, they don't have the internal expertise themselves to do it on a turnkey basis. They're focused on their services and their products. So anyway, with that short introduction, I want to talk about some very exciting work that we've been doing. We've been working very closely with other members in the alliance and with Qualcomm, and this is a really exciting time. So let me see if I can figure out how to do this. Yeah, very good. So I'm going to talk a little bit about our working group first and what we're doing and the key goals and objectives. Then I'll describe the components that are in the open source that we're planning for release in December. So we're coming up very close on the release of our first version. And then I'll talk just a little bit about the services for cloud services we as Affinegy are offering that connect in with the open source that are there. And then some details on developer information. So we're about creating, the AllJoyn protocol has been around for a few years now, and it's wonderful to be in this environment. It's been predominantly around in the home, or what we like to call the proximal network, and you've heard a lot already in the last day in particular. It's important to provide a very secure and standard way to provide remote services and cloud services connections to all the devices that are automated in the home. And that's what we're about, is providing just that. And we're also trying to help provide a way that this is going to be the easiest way and a standard way, so this becomes the primary way. Like good open source initiatives, we're not saying this is the only way. There are other ways you can do it. You can put devices, little app stacks in a mobile device that talks directly out and the usual sorts of things. But what we want to do is provide a way that will be also in the certification program of the Alliance, so that if you include this software application in your product to provide the cloud service connections, then you'll be able to have the confidence of customers as they buy your product of the certification mark that goes with the feeling of comfort and security that is critically important in supporting privacy in the home. So in this chart, you're seeing that essentially all the usual great things that you can do with AllJoyn within the home. The Gateway Agent project is about providing this mechanism to get out to take that AllJoyn app and just take it away from home, and it works just like you were at home. But in addition to that, it's important that if you're doing a product as a service, and this is probably, even though I talked about broadband operators, anyone making a product that's connected, companies doing that are finding themselves as service providers. Whether they wanted to be or not, you're a service provider. So you've got to onboard that customer, support their support calls that come in. Why do that blindly when you've got a connected product? So you have a lot of information, telemetry. You can measure and build into your schema the warranty information. How many revolutions has that motor gone? Even get proactive offers to your customers for things like it's time to sign up for that before the opportunity to extended maintenance ends. You know, things of that nature that have richness in subscriber support. So let me talk a little bit then about what we're doing with the Gateway Edge application. The first release of Gateway Agent is really a project that's targeted at embedded applications, and the obvious example is an internet gateway, a broadband router, or an automation hub. Typically, these are already running open source operating systems. Many of them run OpenWRT, and that's actually the base of our releases. If you build it with OpenWRT, it's very easy to do, but it's not specifically targeted to that. Any Linux application will work. Another key thing is the open source contributions that go in this first release will work with any internet connection. So even though we're calling it Gateway Agent Working Group, it's a device that can be a LAN device. It can be connected with Wi-Fi to an internet gateway. And the NAT traversal technology that can do that efficiently to support millions of devices on your NAT traversal with persistent connections is included in the code base that's available to build your products. So you don't have to worry about port settings or any specific firewall settings. It will simply work when it's connected. You know, AllJoyn, those of you that are really into the depths of it, has many different classes of service, and there's nodes that are routing nodes. Routing nodes are very important in an AllJoyn network. Even though it's peer-to-peer, it's a very key thing to be able to make sure everything is working. The Gateway Agent is providing a special routing node, and the routing node is contemplating external connectivity. It filters the traffic so that only the traffic that needs to go external is sent out external. And I say external because this is also not just for cloud services or remote services. It's also for interfaces to other PAN or personal area network technologies. So we have a standard API to plug in a connector. I'll talk about the components in a minute on another slide. But that connector is intended to be something where any of you that are working in either cloud service connections or other technologies, such as Z-Wave, 6LoWPAN, or others, you could write a connector and plug it into our API for whatever you're doing. And it could be proprietary. You don't have to open source it. You know, the AllSeen licenses are very liberal in what you do and what you connect in your product. So we're really excited to have this sort of architecture available to keep all the benefits of AllJoyn being private, secure. Your customers don't have to worry about everything they do. When they go to turn on the light in the bathroom, whatever they're doing, that's private stuff. And this really supports the ability to do that, yet still provide remote services. We have comprehended kind of two major modes of operation of the Gateway Agent. Now, the first one I'm going to talk about we call consumer mode, and it was really the original conception of the project. The consumer mode, the user, your customer, self-manages the profile for what traffic goes in and out. Now, clearly, our customers don't normally want to write ACLs for routers. So this is needed to be, it will be built in essentially to your mobile app that goes with your connected product. So you make a mobile app for a connected product. There's a component in our open source that's at the bottom called the control app. The control app is an open source. We have an Android sample code in the repository now that you can add to your mobile app. And it talks through an API that's documented and implemented in our code. That code is also in the repository now for that center green box, the gateway management app. That sort of skin-colored layer below there that says AllJoyn router and service profile, there is an API that the control app uses to make the ACLs, basically. So whichever AllJoyn app is in the home that needs to be part of your remote service, part of your telemetry, those are defined by you that makes the app, and then you put in your own UI what level of granularity of, is it a scene because I'm now at home or I'm now going away, or is it because it's time to do a backup and you push backup and then it opens the profile, etc. I'll give one other example. Let's say you make lights and you sell an app that does lights. You don't have any desire to know anything about the refrigerator in your app or your service. So you simply include only your lights automatically in the profile that your app, when they download it from the App Store, creates the profile that goes with your lights, and then you only know about your lights. So those are the sorts of things that we see in the consumer mode. You could enrich that to the level of, if you want to support, I'll call them the paranoid customers, but actually paranoia in this case is well warranted, I think, in many of the attacks that make it in the news. They may be able to have to say, lock it down, I don't want anyone else to know. I mean, this is a choice you can make as you offer your products that will be driven by the market. So service provider mode is able to coexist with the consumer mode. Service provider mode is really bringing in a lot of what Affinegy has been doing for several years, is the broadband forum sort of standards based on TR69, which is a high-scale automated configuration server called the ACS. That's in the top left of the screen. So that's been added. The cloud service is colored the same way because normally this would be someone who's providing a product where their cloud service is close coupled with this configuration server. And then there's a new embedded component on the lower right of the slide, and that embedded component is in the open source, and that is a TR69, what's called CWMP. That's the embedded client that pairs with the remote management. Now, if you're not a broadband operator, why does this matter to your products? So one of the things that in many ways I like to almost not say it's TR69 because there's a lot of people that believe that that's only for broadband operators. As I said at the beginning, if you're a connected products maker, you have a lot of needs that are shared with exactly the needs of a broadband operator. That is to securely register and make it just work when they plug it in. So you can push new firmware at it and know it will work. You don't have to think, well, the firmware push might not work. So if you have some patch, plug-in, some specific configuration, such as I'm selling a product around the world. I've got products that are sold in Asia, Europe, different countries. They have different needs. You don't necessarily have to make a different SKU for every place you sell it. You can personalize it as it first answers and connects. It will get what it needs automatically as a configuration load. So it's a pretty neat concept, I think. And so this mode is, I'll say, likely will be adopted by those that are broadband operators providing managed, connected security services and so forth, and we're certainly talking with them in this adoption. But I just wanted to point out the others. So let me go back to the operation of the device. The connector plugins that I didn't talk about much are very key, and the connector plugins are compatible with both consumer mode and service provider mode. There's nothing different about them. The API between the connector plugin and the gateway management app is documented and it's published. That API will have automated tests available that'll be part of the certification of your product. We're looking at and discussing the idea of certifying the connector plugins. That'll be a kind of a new thing, I'll say, almost in the industry because there's very little certification for software. But this is a great example of a place where we'd love to see that. But at the very least, even if you make a product that uses the gateway agent, testing that your API meets the requirements so that when people write connectors, they'll still work. The NAT traversal in this case for the service provider mode is based on the official and very modern, it's less than a year old standard from Broadband Forum. Not using stun, which is not very efficient. That's been the traditional way for this. It's using XMPP, and it turns out we're using XMPP for a lot more than just this. But the XMPP method can support, well, tens of millions of devices for persistent connections and do that in a cost-effective way. So let me just talk a little bit about how Affinegy is offering services for this. So this first slide is kind of showing the consumer mode version. We also demonstrated yesterday in our breakout this diagram, and in this diagram, I think the kind of key point is that if you use the gateway agent from the open source, the connector plugin, we're contributing and offering a connector plugin based on XMPP. So the Chariot Cloud that's at the top is an XMPP server integrated with our platform that we provide service and support for. I'll back up to say we're religiously focused on standards. So the XMPP is standard. So, and there's lots of open source. So if you want to use your own, go ahead. We offer service to go with ours, but go ahead, do it yourself. And if you've got the skill to do it, you probably will do it yourself, and we recognize that. But what we're contributing is something that, again, interoperation is critically important. XMPP.org has done a very good job in having a very secure, high-scale way to do wrapping of AllJoyn messages. So that's exactly what we're doing with our connector. The connector takes all the services of AllJoyn, wraps them so that the remote device feels just like it's at home. Now we have one other interesting thing you can do. You can put the left side of the screen on the right side of the screen with our connector. What I mean by that is you can join more than one proximal network together as if it's one. And that's using a router or a hub on both sides that are using the gateway agent. So think of how exciting that can be, because now you could have a vacation home, or you could even do this in a large enterprise. And let's say you've got an enterprise network, and now we want to do a business application on AllJoyn where everyone thinks it's only for one subnet. Well, guess what? This is one way. There's other ways, but this is one way you can do robustly a large deployment of AllJoyn and manage it all from one place. We also have, and this is kind of adding the service provider mode, and so Affinegy is providing on a turnkey basis the cloud service platform that will support this. And this is the version including our TR69 platform. We have a remote care experience, we have the subscriber management system, back office integration, all the usual sorts of things you need to sell and support a product. We have, and it's very mature, capable, high-scale software. We've got over 35 million devices under management, or it's really households under management in our platform with the sort of customers I described. That includes mobile app user experiences for self-help and self-care. So we're planning to do an integration of the sorts of things you see in AllJoyn On, which is the nice control panel service mobile app that's available from Qualcomm. And there's sample code of that available in the open source in AllSeen as well. So that provides a really great kind of holistic experience for how you can offer connected products. And we see this as a great opportunity, again, for open source, get everything to interoperate using open source, and the collaboration and energy and excitement that has been here and yesterday and today is something I'm really thrilled about. So here's the AllSeen information, and we have a wiki page that is where you want to go. And if you can't, I mean, these slides are available, but that's the place. It's easy to find, and we have a weekly meeting. Josh Spain in our team is here also. He leads that meeting for us with the contributors. The meeting is open. Everyone's welcome. You don't even have to be a member to participate. If you're just interested, you do, and we have people that call in every week. As well as that's where we coordinate the project details and plan. It's busy times for us because we're planning to hit this same timeline as 12/12 for the Alliance, 1412. Wow, it's not 2012 anymore, 1412. And so we're based on 1406 core, but releasing simultaneously with 1412 in terms of the dependencies. I think that's it. Oh, this is important. So these are the people that are actually committing code right now into the project. It's very active and really welcome participation from any of you that are interested. I'm especially wanting to have people that want to make connectors to be part of it and influence what we're doing. The other thing, of course, is those of you that are interested in security and the implementation for these things, and this is obviously at the heart of one of the most important parts of security. We're all ears for what are your requirements or things that you would like to have supported so that we can catch it either. It's probably a little late for this first release, but there'll be another major release that goes with the 1504 release where we bring in everything we can of Security 2.0 that's going on right now in that release. So any questions? Well, you can only, to follow the standard, I'll say it this way because I actually looked at applications where you have more than one client running a device. So, and in fact, I think there may be merit in that, but I'll come back to that in a second. In general, a gateway device can only have one ACS, and those can be made, scaled, and you can use DNS tricks and things of that nature, but to have them regionally, and we do that all the time. We've got ACS servers 1,000 miles apart that are supporting a large deployment. But the fundamental answer is no, you use one client connected to one ACS, and that's how you do everything. That said, gateways now are modular devices with installable software. So you can run and provision your internet services on what you've been using for years with I'll call it a likely legacy internet gateway device, TR98 based TR69 client and ACS. Our TR69 client that's here is the latest, most advanced there is, and it's implemented in a very modern way, and it's fully supporting OpenWRT. But it's TR181 device 2, extensible object-oriented data models. You can model virtually anything with it. You could model a DSLAM with it if you wanted to and manage it. Because they're stackable objects and so forth. So it's a very powerful contribution, and our ACS fully supports that as well. But back to your specific question, you could have an automation service running out of a gateway in an application. That application is being managed by the ACS, like for hours, for example, and maybe you're using Alcatel-Lucent's ACS to do your internet provisioning. There's absolutely will work. And we've been looking at projects to do that. We don't have any currently deployed that way. But we simply have to use a serial number or some other information other than the MAC address, because in the database, every gateway is unique, and it's usually identified in a particular way. So we just need to supplement that, and that's actually very easy to do. You could imagine an OSGI gateway with a modular plugin. Well, I didn't mention it. I should have. The Package Manager is a very key component in that slide on the components back there. Package Manager is to allow either the consumer mode, the mobile app, to bring its own connector and install it later. So it wasn't in the hub when you first bought it, but it gets added later. You could treat the entire, and by the way, you can service provider mode, you can do that from our ACS. The ACS can control the Package Manager, the service profile. And one other key thing, we talked about this a lot in the breakout yesterday, is service providers sometimes want to block any change or any other device that isn't under their management. They could choose to use this software stack to do that by they write the service profile that way, and the remote management server configures that. Any other questions? All right, well, thank you very much. I really enjoyed the opportunity.